Welcome back, PlayBASIC coders. Let's have a quick look at the current development version of the classic version of PlayBASIC. Brand new feature, something that I wanted to do a while ago, wasn't sure how to implement it, and all of the work with the draw mode stuff I've been doing lately, that's been enough of a refresher to get this to work. So what we're looking at is palette mapping for images. Let's take a look. We don't have a palette map surface type. That's a bridge too far in this revision. I do like the idea of doing that. It would be probably 16-bit, maybe an 8-bit surface. So what palette mapping is you've got, rather than each pixel representing the RGB color of that pixel, it's an index to a color table of the colors. So you can pre-compute the image, the texture, however you like to think of these things, and then modify the palette while the thing's running and see the effects, which is what we're seeing here. So in this program, what I'm doing is I'm creating a couple of arrays called palette 1, palette 2, initializing the palette with a kind of sinus table. We're making a palette. This here is just displaying the logo. We're going to make a scene full of sprites. So each sprite, I've made a separate image for it they're all 256 pixels square. I'll have a look at the routine. Just creating a normal effects surface. So rather than draw RGB colors in this, we're drawing the indexes of the pixel. So I'm using the palette mapping library that's been around for a while now to do that for us, but really we're converting this distance in this case here. I'm stepping through each dot in the image, applying a bit of an offset to it, and then reading that and using that distance as what color from the palette to place at this location. If you've ever seen demo effects, it's kind of the classic sort of plasma effect that you would have seen in the demo called Art by Sanity. The key point here is we're not drawing colors, we're drawing the index to the palette array in each dot's position. If we just look at the background picture, this shows that particular image being drawn without the palette being applied. So there's nothing really to see there, is there? It's just a very plain looking image. Put the foreground sprites back. If we take away the blending of the foreground, which is something I wanted to show off because it wasn't possible before. You could kind of do palette mapped effects, but you sort of had to stay within the constraints of the classic rendering, the classic 16-bit rendering in particular. So you couldn't have sprites rendered with any pixel effects. You can kind of do it now, but there's caveats on that as well, because it all depends upon where the palette mapping process is done inside the rendering for each sprite. So all these little plasma blobs are sprites. Each one's a sprite. They're all using the same palette, and I'm using dynamically the diffuse color, or we call it the tint color in PlayBASIC, to modify the palette real time. So these could rotate, scale, whatever you want. So we've got to create the palette, we've got to create the texture of color indexes. Once we have that, this is actually a test build of this. I've patched this into the old color buffer palette stuff, which is very old and out of date now, and it's not supported by the renderer. And I haven't been able to come up with a way of making that work in the current renderer. It's a very powerful system, but it's the way this was implemented way back in the day. For those people who don't know, this was a feature that let you substitute a particular color in a sprite at render time with a particular color from that scan line. So you can kind of simulate an old effect like raster bars or these things from the 8-bit world and the 16-bit world. When the renderer was rewritten for 164, which is, geez, I don't know, 15 years ago or something now, that system, it doesn't work anything like the old one. The new system allows you to read from any texture depth you want, apply an effect, write that effect out to any texture depth you want. That's the whole purpose of it. It has this sequence of events that occur inside the renderer that I can switch on or off. To add palette to these images, what actually happens is when the sprite is being drawn, we are grabbing from the sprite or the texture, it gets dragged into a buffer, then we run through that buffer and use those, well, they'll be color indexes, they won't be colors, but they'll use those as to look up a color from our palette that's associated with this particular sprite. In this case, we're using an array. I think what I might do actually is I might just make that a pointer, which, you know, it's probably a little bit more dangerous, but, you know, because the onus then is on you to make sure that that palette you created and that buffer you created, you don't delete it at some other point, because it won't know. If you delete the palette somewhere else and you've got a sprite in the scene that still is using that palette and the renderer tries to access that memory, you'll get a crash. That's what will happen. But because this is part of the sprite rendering engine, and it's part of the steps the sprite renderer goes through in order to render your pixels out. So we've got like a pre-processing step where we fetch the data from the source texture. It's translated, transformed. We've removed mask color, all those things. Then we run through the buffers. And in this case here, I'm doing, well, how it works internally is we do a palette remap if that's been activated, if this blend mode here is activated. Once we've got the remap, we've got an internal color buffer of this sprite that is now just RGB data. So we can just apply the regular sprite effects to those as if it was RGB data all the way along. It wasn't, but that's what it looks like. So when we render out, we're rendering RGB data to the target destination. We're not rendering color indexes. We don't have a surface inside PlayBASIC that would be treated as a color index or a palette mapped image format. All of our image formats are all RGB packed. So, you know, if we had a palette mapped surface type, which of course the problem is there is that you couldn't render RGB data to that. You would just get a mess, you know. You might, you know, find a useful way of making that effect, but making an effect out of that. And you can do this with this too, is that this will use the RGB data that it grabs from your texture, and you can just reapply it to something else. So you could like remap something real time, have the pixels, the colors change to something else just by changing the palette. So anyway, a little loop here is we're just making some sprites that runs through and to render our little scene. I'm making an image for each one, making a sprite, giving the sprite the current palettes, because each one could have a different palette. So you could have, let's say, two characters that you've drawn. You want like like a Street Fighter situation where you've got two characters that have the same basic body, but they're different colorings. So you could do that. Here I've got the tinting, where I'm just giving it a color to multiply the RGB data before it writes it to the target screen. Setting the draw mode, This is rotated plus the blend mode. This is disabled at the moment. The beauty of having this thing as being part of the Sprite system is you've got the pre-pass, which is the reading pass, the modification passes, which are things like the palette and the tinting and adding of colors and adding of ground shading stuff to the sprite. And then you've got the output pass, which writes that modified pixel data out to the target buffer. So which supports classic things like just plain alpha blending, alpha 50/50, alpha addition, and alpha subtraction. There is room for an alpha multiply, and I probably should insert that actually. Unfortunately, we've got things like the way draw modes, the way the ink mode bits are set up and the sprite draw modes are set up is they kind of collide with each other. So I should have added the same things. Should have added sprite draw modes being an extension of ink modes, but I can't really change it now. It would break too much old code. Anyway, see, you set your sprite to this, you get that. If I turn palette mapping off and render it, we just get the source. It's just reading the source pixel data, and in this case, it's doing a blend mode to output it. We disable the blend mode, we just get all foreground. So they're different colors because the tint is actually changing the color for us. Get rid of the tint. Restore all that stuff there just for something nice to look at. That's the only thing in that demo that's actually different. Is this this palette map mode. Now, I could add this to things like textured polygons. Those people who are familiar with how the PlayStation worked and Sega Saturns and these old, very first generation of 3D consoles, they had palette map textures. And in fact, old GPUs on the PC had palette mapping as well. It just meant that your texture data was, each texture can only have a limited number of colors, whether it was 256 colors or 64,000, or whatever the amount of bits they were willing to use for the color indexes. So you can only have that many, let's say it's 8-bit, for example. You can only have 256 unique colors, but the colors themselves could be 32-bit. So it's a great way of compressing down the texture data. And if you wanted to add effects, like a texture that's 256 by 256 is still 64K of data. It's a lot of pixels to do blend effects on. So in most cases, all you need to do is just modify the palette and then output the modified palette data to the target. So things like blending, for example, like you're reading from a palette map surface, you've got to do a level of alpha blend across all the pixels so you can pre-compute the RGB blended values, which is going to be just 256 of these blends, which is a lot less multiplication. And then the target has to be multiplied by the opposing level of blend, and then the results just added together. So a lot less work. But I've always wanted to have this be part of PB. It never really fit, and it's kind of been, I've kind of made it fit in this case here. I'm not sure how useful it's going to be, but I mean, classic effects were things like sort of waterfall animations and even rain animations. That kind of stuff was done with palette mapping. Looks pretty good. That'll have to do. Alright dudes, I'll see you next time. Bye.